right, any second now, any second now. Chickity check, check, check. Let's try and prefix the chat. All right, maybe that fixed it. Who knows? We'll find out. Hey, happy whatever day it is. I hope you're having a great one. I am having a great one. No music today though, because pretty much every video that I've done that had music on it got a copyright strike. So a little bit of trouble there. It'll be fine. But no music today. So yeah, we'll see how that goes. Maybe it'll make things better. I doubt it. All right, given a binary array, find the maximum length of a contiguous subarray with equal numbers of 1 and 0. This sounds really familiar. Huh, okay. So again, we've got a dynamic problem. We're gonna loop through, and in this case, we've got a 0 and a 1, so that's balanced, so it's 2. And here we've got 0, 1, 0. Either way, this is gonna be 2. Okay. So we did maybe this exact problem once before, so that helps a lot. There's a lot to be said for doing problems like this. And how we did it, whoa, wrong button. That was the ruin everything button. Whew. All right, fixed. What we did is basically treated zeros as -1, 1 as 1, and if sum equals 0, we're balanced. So every time we go on, we have to decide whether or not to start over or to continue. So if we look at this long array, that's a little too long. So here, if we did a running sum, we would start out with 0, balanced, and a length of 0. Call this max length. So sum equals -1. All right. -1. And when we go here, the sum goes to 0, which is good, which makes our max 2. So here we go, -1. So we're out of balance. Go back into balance. Our sum is 4. This is, let's do it like this. So we're here. We're at 4. We're in balance. We go here. Our sum equals -1. And our sum equals 1 again, which makes it 5. Sum is back down to 0. And then when we go on to the final one, we end up with 1 at the end, and we don't change our max. So our max here was 5. That is true. Not very exciting though. Let's try something like this. So here we need 3 1s to offset 3 zeros. So we've got a max length of 6 here. So what it would look like here. Sum starts out as 1, 2, 1, 0. So every time we hit 0, we can keep the length. Does that sound right? Man, I know I did this problem before. Huh. Reminds you a little bit of the algorithm we did the other day with Kidane's algorithm. We looked that up. And the way that worked is basically we would have to decide whether it was better to start over at every step. But we don't want to do that here because we could be balanced off like later down the line. So we don't ever want to restart. So we could have an example like this. And this whole thing could be balanced. But we're not going to know. So if I go just left to right here, my sum is going to go 1, 2, and it's going to go to like, I don't know, negative 14 or something. But when it hits 0, there, I can keep track of my max equals 4. But what I'm worried about, and eventually we'll get back to 0 and we'll record the new max. What I'm worried about is like if we have a bunch of like garbage here, and then it ends up being balanced at the end. So here, like if I were to just keep a running sum, I'm going to get way out of whack here. That's no good. And then from there on, it'll be balanced. So if we treat it like this, like a dynamic program, one thing we could do is basically keep count of the best solution so far as we go along. We come in here, we start with 0, it's balanced, so our result is 0, that's fine. And we come here, now it's negative 1, no, sorry, it's positive 1. So we don't have balance. So what do? We either say you're in or you're out. How does this help us? Either we start at this index or we don't. Okay. If we start at this index, we go to the next. This is garbage. This is not good. This is a bad solution. If we started at the end, it really doesn't matter. Man, I swear I've solved this one before. And I bet you had a hard time with it. Maybe even cheated. Don't want to cheat tonight though. Want to do it good. All right. Keep an array. If we come here. Yo, 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 what's up, Chris Moore? All right, and the chat worked too, first time. Awesome. Definitely going to get it. Am I on the right line? Am I thinking correctly? Maybe keeping an array here. And either I start with this one or I don't. If I start with it, then I don't know. I have to do a bunch of math along the way. Seems like a bad idea. If I were to keep a running sum, then I would keep going on. Dot to dot. I don't know. I'm just going to make up some number. Negative 12. And at some point, it's going to start getting better. All right, so we may not get all the way down though. So let's say this is as far as we get. So knowing what I know now, I know that we could hop back from negative 6 all the way to the last time we saw a negative 6. Oh, I think that's good. I think that's good. So what does that mean? Let me try a smaller number. Let's put a few more. Let's do zeros too, a little easier. So here, my answer should be 4, and I seed it with a bunch of bad values. So here, I would go, my running sum would go oh, man. Okay. I got it. All right. Here's what we do. we keep a hash. There may be a better way of doing this. And the hash is going to be the numbers that we've seen, and we'll keep the indexes. So here, this will be a -1, and that's at index 0. So -1, linked list has like a 0. Okay, boom. Next, we got -2. All right, and it's at index 1. We got a -3. Index 2. We'll get a -4 and a -5. -5. Whoa. Oh my gosh, I can't type. It's index 4. Now, here, we've got a 1, which is going to bring our sum, which is currently -5, goes to -4, which we've seen before. So here, boom, we keep my index. So we know that -4 stretches between indexes 3 and 5. 0, 1, 2, 3, 4, 5. So it looks like I'm off by 1 there. But if I subtract 5 by 3, I get the answer 2, which is actually the answer I want. So how did I screw this up? Should have been 5 zeros. 4, 5. And then this should have been index 5. So, I mean, 5 minus 3 is 2. That's okay. When I go back to 0, I go back up to -5. Which means that I, again, have a maximum string of 2. And then, so that actually got worse. We add another 1, which goes to -4, which means we can add the 7 here. And then we've got a 0 again, which brings us to -5 again. Which brings us to 8. So now, and I could have skipped those numbers. So basically, the longest substring is either from 3 to 7 or 4 to 8. So the longest length is 8. So I think this is a good solution. This is good. So I'll go ahead and pop this into IntelliJ, and I think this is going to be an easy one to code. And it helped a lot that I've done either this problem or one that was very similar. And how's it going? Well, I haven't seen you streaming in a while. I also haven't been watching a lot of Twitch lately, so that could be it. This one is contiguous. Array test, like that. That's fine. All right, so what we do is we keep dad life, yeah. Oh man, kids going back to school yet? Just kidding. Year's over. That's terrible. Sorry, bad joke. Yeah, it's with the streaming, I don't prepare at all, so that's how I do it. Let's see. I don't want X. That's terrible. What do I want here? I want hash map. So we'll call this ranges. It's going to be an int for the key, positive or negative, and then for the value inside, I kind of just want to do a tuple. So a pair of int to int. And I could have done mutable map of, that would have been better. All right, let's see. So now, nums dot for each, we got an O of n runtime. I do care about the index. What do we want to do here? Index and I are the default names. I don't really like I here. Value. So we also need a sum, which is a variable. Start it at 0. And how we do this is if value is equal to 0, sum minus minus, else sum plus plus. I could have done that in a better way, I'm sure. A when statement would be neat too. Yeah, let's do when. I don't do when enough. When value equals 0. Wait, what did I do wrong? Oh, duh. Maybe I don't know how to do a when. Maybe that's why I don't do them. I thought it was just like kind of pattern matching. Let's see, when x. Oh, yeah, okay, cool. When x. When it's 0, we'll. What's the best way to do this? Sum minus 1. Else. I got that all wrong. Else goes in a block like that? Okay. Or else has an arrow, I should say. Okay, sum equals when this, else that, because Kotlin doesn't have a ternary operator. And Go doesn't either. We talked about this on another stream. It is upsetting to me because I like ternary operators, but I looked up why Go, or someone else looked up and shared why Go didn't have a ternary operator, and it made sense. Said they don't nest well, they look ugly, and if somebody else comes to modify that later, you end up having to break the thing out anyway. So it's not something that like you either break it out or you have it look terrible. Yeah, exactly. But I like that. I mean, like if you've got you know, sum equals 0, then 1, otherwise negative 1, something like that, and you go to edit it, and you're like, oh, but I need another statement in here, then you can't just edit it. So I didn't look up what Kotlin did, but I assume it's the same thing. Oh, if sum, or rather, if ranges at sum, or I can say contains the key, then what we can do is say ranges at sum dot second equals index. Val cannot be reassigned. Oh, pair is immutable. Is there a mutable pair? Well, mutable point. I guess I could replace it. Fine. And like that. So ranges at sum equals items, the first item and the new index. Right. It's there. I just checked it. What? Oh, bang bang, sorry. No question mark. Okay, and then what we could do is basically keep track of the biggest one we've seen. Start with 0, and then ultimately that would be what we return. And range is at sum dot second minus the first, and max range equals either whatever's bigger, the item that we already had, max range, or our new sum. Okay, it's there. I think that's it. I think that is it. I'm feeling lucky. So we're not going to write a test for it. Just going to try it. And negatives will be good. Okay, my answer was terrible. Max range is max of 0 or... Oh, I never added to my... Phew. Okay, so if it contains the key, I replace it with a pair. Otherwise, what we do is just put in a new one equals pair. Yeah, exactly. And this is kind of dumb. It's dumb to put a pair in here. Like, I don't like this part. Index and what number do I put in here? You know, it's kind of like a weird... Yeah, it's just dumb. 0, I guess. So yeah, I don't love having that pair in there. I mean, I could have done a list, but I only ever want to keep the bigger one. Yeah, minute's better. Good call. Jur.minute. It's more readable. It's like, it lets you know that this is kind of flagged for a reason. 0 kind of has a meaning, but if you see if you see a negative or a integer.min value, you know it's kind of a... It's not part of the logic. All right, I got the wrong answer again. It gave me a 0 and a 1, loop through, index, sum equals, did I get index and value mixed up? Index and int, okay. So index and value. So when value, when it's 0, we set sum equal to sum negative 1, otherwise sum plus 1, when it's 1. If it contains the number, we replace the pair with the first item in the pair and our current index, and the max range equals whatever's bigger. The current max range, or this item's second minus its first. That looks good to me. Otherwise, we pre-populate this mutable map with pair and integer max value, or integer min value, sorry. So yeah, I don't know. Time to write a test. Fun basic test. Not feeling very creative with the test names tonight. Find max length. And I believe they pass an int array of 0 and 1. Result equals, and result should have equals, result should have equal 2. Call this actual. And this is going to be wrong. And then we can debug it. Okay. Yeah. There we go. Okay. I need to do something about this yellow. I can never read it. So sum is 0, value is 0. Okay, sum is -1, correct. It does not, so we're going to pre-fill. So now ranges has an item -1, and the value is equal to a pair, which has the first index 0 and the second of really big number, really small number. All right, we come back around. Whoa, we jumped too far. Okay, now sum should equal 0. Yep. And, oh, probably missing a map entry for 0. You're totally right. So, yeah. So here, the sum, yeah. So that is the problem. So what's the right way to fix that? So here, by setting it to -1, when it comes back around and we get to 0, we know the whole array. So yeah, I guess I just need to pre-fill it with the 0 because that's a special case where the whole thing is balanced. Ooh, setting 0 to -1. Yeah, good call. Good call. Ranges dot ranges at 0 equals -1. Because if we ever get a 0 again, and dot min. Yep. Okay, so we'll just give this the answer that we expect. So here we would have gotten 0. We would have gotten it on the second index, which was 1. 1 minus -1 is 2. So we would have got 2 for the answer, which is correct. So this will now be correct. Test is not finishing. I swear I have to start IntelliJ twice every time. But I'm willing to put up with it because I love IntelliJ so much. All right. Let's try that again. All right, and there we go. Let's try lots of 0s. I think we're good. So here I should still get a 2. Just got a bunch of leading 0s. But we may not because I've pre-filled. Okay, that worked out. Wow. Oh, because, right. That's good. Yeah, because this would have been like -1, -2, -3, -4, -5, -6, -7, -6, which balances out with that index, which gives us a result of 2. All right. Oh man, did you try yesterday, Will? Oh man, I cheated and still had a hard time with it. Oh, it beat me up. I cheated, finally got through it. So I looked at the discussion and saw how other people solved it. Still didn't really understand it, not at like a deep level. Programmed it. Oh man. And then yesterday, oh, it was so bad. I'll show you what it looked like. All right, so not the greatest. Let's see if you want to do anything drastically different. Oh, they kept an array instead of a hash. That's fine. So the space complexity will be a little tighter. So I guess the big O times don't really change, but it's just more efficient. So it's mo better. But yeah, check out yesterday's. How do I get back to it? Oh, uncrossed lines. Yeah. So they give you two arrays and they want you to line them up basically horizontally, one on top of the other. And you want to find all the ones where you connect the numbers in the two arrays, but you can't have the lines cross. So in this example, 1 connects to 1, 4 connects to 4. You draw two lines to numbers that match without crossing. You can't draw a line from 2 to 2 because that would have crossed a previous line. So the wording was awkward. The hint they gave you was awkward. No lookbacks, yeah. So the algorithm ended up being n squared, and you can see down here the biggest hint they can give you is that the array length is only 500. So they were expecting a big runtime. And yeah, good call on that, by the way. Seeing no lookbacks, it took me a lot longer to get to that realization. So n squared, no lookbacks, and you basically, it was kind of standard dynamic, but it just ended up being kind of finicky. So you kind of had to keep track of like, well, if I started here, what's the best answer? If I started here, what's the best answer? So let's see. That's what my solution ended up finally being. But yeah, so it wasn't, it's like 20 lines, but it was just a lot of like kind of, comparing the previous best answer to see how you got it. So it was just awkward. But it was very similar to today's solution that or that I created an array that was just one item bigger than the array that we took in. And then that let me pre-fill that value to a 0. Just ensure that index of element is greater than 0. So if you had an example like, I'm going to do like 1, 2, 3, 4, and then maybe 4, 3, 2, 1. Would that break that? You mean greater than index of other array. So here, the 1 and the 1 greater than index of other array. Yeah. Yeah, I think what you said is true. But you have to do that starting at each point. If that makes sense. So, I mean, this is kind of a dumb example because there's only ever going to be one. So what's a better example here? Like maybe if we did like, let's see. If this was like a 4, then that would do it. So if you go starting here, 1 links to 1, 2 doesn't link to anything, 3 links to 3, but it crosses. 4 links to 4, but it crosses. So yeah, I guess you could say, yeah, so shortcutting it, in this case, we never have to look past the 1. And yeah, I kind of end up doing the same thing effectively because, no, I don't. I should have. Yeah, you're right. I should have, instead of resetting J to 1 every time, I should have just left J at whatever the farthest match I had was. And then that would have shortcutted out of my loop sooner. Yeah, so good call, man. You would kick this one's butt. So then you start at the 2, that has no matches. 3, you do have a match. And then when you go to 4, it's not, you could basically start at this index to look. And you would have seen that there's 2 lines you could draw. So yeah, that's totally good. Yeah, good call. Yeah, and then the rest is just kind of, dealing with the, the kind of finicky matrix stuff. Not too bad. So yeah, after talking it through now, I feel better about this problem. So I'm going to add this, to, how do I add a bookmark in Firefox? Problems, I want like a folder. It's like problems I want to do again. To do again. I should have started this one a long time ago. Code, sure. One of these days I will go back and revisit this one. Cool. I guess I could probably star it on here somehow. Or not. So yeah, I spent forever on this one, and ultimately the stole my answer from here. That was pretty cool. Some of the terminology was kind of weird too. Have you ever heard they mentioned Oracle? They weren't talking about the database. It was in the hint. Think dynamic programming giving an Oracle DP I and J that tells us how many lines A at I and B at J for the subsequence going forward are uncrossed. Can we write this as a recursion? I didn't recurse, so I didn't. This just the way it was phrased really threw me off. But they mentioned Oracle DP, and I didn't know if that was a standard term. Yeah, I tried Googling it, and you can imagine what it's like trying to look up Oracle and anything programming related. Like Oracle DP, data pump, dynamic programming. Yeah, so I didn't get anywhere with that. Coding dynamic SQL, no thanks. All right, cool. Well, that's it for me. Add to list. Maybe it's because it's in the kind of contesty thing. Maybe if I just like Google it. This is how I cheat, by the way. I basically Google it, and then you go to discussion before you solve the problem. Which definitely, I don't recommend it. But I was a half hour in and had like zero clue. I was like, all right, I can't be here for 4 hours. So let's see, add to list. There we go. Create new list called Beat Me Up. Public, sure. All right, cool. Yeah. Also, I didn't like this one, so I thought the description was pretty rough. Yeah, and I did watch somebody else program it while coding, and also mentioned the problem being tough. So tough to understand because of how it was phrased, and the Oracle thing was just weird. So thumbs down. All right, cool. Well, I'm gonna get out of here. Hope you have a good one, and have a good night.